Okay, so this is just an introduction into the whole concept of operating systems, and we say it's used to control hardware, and common platforms are Windows, Unix, and Mac. Also, as part of the Thursday lecture, there may be 1 or 2 slides that were included, okay? But all of this is coming, I'm not making all of this up, it's coming from the study guide. So if you compare the stuff, the points in the study guide, you're going to see that we cover them extensively in these slides. So we covered the learning outcomes, describing an operating system, list and explain the functions of an operating system, discuss evolution of operating systems, define virtual machines and virtualization, okay? Discuss the basic structure of Windows, explain the features of Unix systems, and explain various layers of Linux. Okay, so we say that the operating systems functions the same way as ordinary computer software, which means the operating system itself still requires help from the CPU, still requires help from the for primary memory. Okay, it needs all of those resources. It operates like how normal software would operate. However, the operating system is viewed as an ecosystem of applications. Okay, so when you first install it on your computer, you may even notice when yourself, what does it come with? It already comes with applications. So it's an ecosystem of applications. It really comes with Recycle Bin. It already comes with the web browser. It already comes with the media player. Okay, so frequently relinquishes control and must depend on the processor to allow it to regain control. So sometimes the operating system may compromise itself, usually the graphical user interface, to boost performance for the user. Okay, once there is enough memory for it to give the full experience, then it sort of boosts the graphical user interface again. So this is also an additional concept that was added to this lecture, and we want to talk about Unix. So Unix is referred to as a kernel, okay? A kernel is a lightweight operating system. It was previously referred to as a monitor, okay? So a kernel is a lightweight operating system or program that sits on the memory. So Linux and Mac operating system are all built on top of this Unix kernel. That's why they share similar properties, unlike Windows, which is manufactured by Microsoft. So Windows, especially in the sense that it has its own specific kernel. That's why you cannot install software or drivers from a Windows machine on a Unix-based machine, such as MacBooks and Linux computers. Okay, so Unix is an operating system which is very powerful. One of the things that actually make Unix very powerful is the fact that it doesn't require that much resources to function, as opposed to Windows. It actually requires a lot. Since it contains a lot of wizards. Okay, it's very graphical, so it's going to require more resources to function. So the Unix kernel is powerful because it does not require that much resources to actually perform the tasks, making it more efficient. So Unix refers to an operating system that runs on Intel-based processors, was originally developed by AT&T to solve scientific problems. Later on, obviously, they implemented it for workstations and server computers, but the user interface of Unix is very complex. So unlike Windows, where stuff is done in wizards, you just click next, next, up until you finish whatever you're doing. When it comes to Unix-based operating system, it's usually a bit more complex, okay? With the exclusion of Mac. If you noticed on Linux, if you want to do a basic thing like installing a software, you really have to go to the terminal, start to type commands and stuff like that. That's why most people that tend to use these computers running Linux like to brag that they are more experienced developers and stuff like that. But quite honestly, my personal opinion, I feel like I prefer Windows because it balances that aspect of convenience and power. Okay, Linux too powerful, but it's inconvenient. Also, what you need to know about Unix is that it has sort of been developed to be the more cost-effective operating system. So if you want to develop your own operating system, you can use the Unix kernel to do so because it's available for free, it's open source. And hence, most of the operating systems built on Unix kernel do not require you to buy a license before you use them. Okay, you get them for free on the developer's website. For example, Oracle Linux. If you want to use Oracle Linux on your computer, you can go to Oracle website, download the ISO or the image file, install it on your computer for free. Okay, so that's the other Unix versus Windows kernel. Which one is better? It depends on what you want to do. If you have a lot of money, then you can go with Windows because Windows is has become also the industry standard. Okay, for various reasons. Some people state because Microsoft is actually a monopoly, so you don't have a choice. They've bullied the companies into using the systems because everything is so Windows based. So Unix is more of an open source framework. Things are available for free. Everything that's built on Linux, on Unix, people can get it for free. Android as well, very popular. The Android ecosystem is also one that subscribes to the open source philosophy. Hence, you see Android on most device manufacturers, mobile devices on smartphones. You see them on a Samsung. You see Android on a Samsung. You see Android on a Huawei. You see Android on a Hisense. Why? Because Android as an operating system is built on top of Unix. Okay, and Unix is open source. However, Google has purchased this Android operating system. So to some extent, as a hardware manufacturer, if you want to install Android onto your hardware, you may need to purchase a license from Google. Okay, but at the same time, there are different versions of this Android. So what are advantages of Android? Reduce startup time of applications, improves battery life, okay? Less RAM or primary memory is required. All of these sounds like what we mentioned, the benefits we mentioned about Linux, okay? For the mere fact that Android is also built on top of the same framework or kernel. So what are some of the objectives and or benefits that were brought about by operating systems? We say they are convenient. The operating system allows the users to interact with the computer in a more friendly way. Users are able to interact with the system through interfaces, okay, through screens, through wizards, more easy, more convenient. It's also efficient. You don't have to keep on typing manual commands onto a computer using an input device. So with the operating system, some of these tasks can be scheduled, they can be automated, making it more efficient, okay? And then also ability to evolve. And later on, we're going to talk about how operating systems actually evolve. So they don't remain the same for a long time. They evolve, adding extra functionality, tweaking and improving the user interface, and so forth. So before operating systems existed, computers they've been around for a very long time, before the concept of operating systems started to gain traction. There was a lightweight operating system equivalent, okay? But transactions or instructions were executed in series, okay? So we refer to this as serial processing, one after the other in a very linear manner, okay? Which is good because it was an improvement on the manual system, how we manually do things. Okay, we have a computer now doing these tasks for us, but at the same time, the concept could have been improved. So there was room for improvement because serial processing, as time went by, started to become more and more unsustainable. So some of the functions or some of the benefits that are brought about by operating systems. So they perform common hardware functions, which means they manage our hardware, our hard drives, our CD-ROMs, floppy disks, and so forth, are managed by the operating system. It provides a user interface, which we already discussed. It facilitates communication. Okay, you can't set up a network unless the computer has an operating system in it. So that in that sense, it facilitates communication. Okay, it also enables device management. The operating system manages devices using device drivers. So it picks up the devices using the device drivers, and you can manage these devices. You can disable them, enable them, update the drivers, and so forth. Also allows for file management. For the fact that we store our files in folders and we can search using Explorer, we can search for files and find them more easily. It makes it more convenient for us to navigate around the computer and find the files that we are looking for. Okay, so also the file system. Okay, I see no hands, so no questions so far. Right, so also the file system. What are file systems? So file systems manage our operations on a computer. So they focus more on storage management, okay? File naming conventions. A file on a computer must have a name and must have an extension for the computer to recognize it, okay? It must be stored in a particular directory. A file must have permissions assigned to it, whether full control, read, write, modify. Okay, so thanks to the file system, it helps us to manage operations relating to how files are stored and retrieved on computer hard disks, on permanent storage, which is our hard drives. And the two common file systems are NTFS and FAT32. Okay, so with the introduction of file systems, it ensured that we were able to enforce security and protection on the computer. Okay, so certain users are assigned certain permissions based on the file that they're trying to access. So access control to resources forbids intruders or unauthorized users to enter the system, forbid user processes to access resources which are not authorized. Okay, so through the file system, we enforce we enforce authentication. That's why sometimes when you're trying to delete a file on your computer, it wants you to prove whether you're the administrator or not. If you logged into your computer and you're not logged in as the admin account, you logged in as guest, you're not going to be able to do certain things. You're not going to be able to install programs or edit files. Okay? So
sorry.
Yes.
That Abdullah guy is switching on his mic.
Which guy?
Abdullah.
Oh, okay. Does Abdullah have a question? Perhaps they have a question that they wanted to ask, or it could be accidental as well. Okay. So, but thanks for letting me know. Okay. So we say that the file system allows us to enforce security and protection of files. Okay, but also when we protect files and directories, what are we actually protecting? We're protecting sensitive information, because when somebody wants to open up, maybe somebody wants to open up your payslip on the network or on your computer. Okay, so you let somebody log in and use your computer, and then they stumble on a file called payslip. So what are they actually trying to do? They're trying to gain access to information. So as much as we say operating systems secure files and directories, but they are very good because they protect sensitive information, okay? And we tend to use these particular factors to measure this. We say they provide availability, which provides protection against interruption. Okay, so people cannot fidget with files or delete files while you're using them. Confidentiality prevents the user from reading data that he or she is not authorized to read. Okay, so thanks to the file system that comes part of the operating system, there's confidentiality. People log into the computer using user accounts, and it makes it more convenient. There's also integrity. No modification of data that can be done by unauthorized people, which means we can trust the data. The next time we're opening it, we can trust it because it has not been modified. Okay, without the file system, people can go in and modify fake data, commit fraud using the data, which means that data will slowly lose its integrity. We cannot trust it anymore because multiple people have sort of modified it and manipulated it for their own use. Okay, and also authentication. Same thing I was talking about. I said the administrator of your account, you have full control of what you do with your files and your data. Okay, so we've seen this a lot. All operating systems allow for authentication, creation of user accounts. Okay, your phone, our smartphones also do authentication, but obviously for single user. I don't think I've come across a smartphone that allows you to add more than one user because it's a single user type of system. But on our desktop machines, we definitely can add multiple users and enforce authentication and authentication policy. So we say that operating systems tend to evolve, but for what reasons? What causes operating systems to evolve? Upgrade of hardware. Manufacturers of hardware are always constantly releasing new types of hardware. Let's say, for example, the graphics card. There's always a new one that's going to come out every single year. So the operating system has to be able to evolve along with the hardware vendors to take advantage of some of these new features that are brought about by these new hardwares. Okay, so that's one of the things that causes operating systems to evolve. Changes in hardware or hardware manufacturers releasing new hardwares. Okay, the introduction of new services. So there's new technologies, new services that are released. And I made reference to cloud computing. Okay, so cloud computing is the new thing, and this operating system vendor now needs to ensure that from our operating system, our users are able to synchronize their files or folders to the cloud. So you can imagine how the introduction of the cloud forced operating systems to evolve because they need to be in sync, be able to synchronize this data. And then the most popular reason why operating systems actually evolve is because of bugs and fixes. Remember, out there on the internet, there's all of these threats, okay? And the database of these threats is constantly growing. There's new threats that are being released, threats such as ransomware and so forth. So the operating system manufacturer may need to release fixes or bugs or patches to sort of counteract these new threats. So these are the common reasons why operating systems tend to evolve. So then we now talk about the monitor, also referred to as the resident monitor. And I said earlier on that in modern operating systems, we no longer use the term monitor. We use the term kernel. So we refer to it as a kernel. So Windows, Microsoft will have its own kernel. Unix is a separate kernel, which allows, since it's free and open source, it allows other operating system manufacturers to build their own operating systems on top of Unix. As opposed to Windows, it's proprietary and it's licensed by Microsoft. So how did computers perform functions and tasks before operating systems started to take off? Okay, so the resident monitor, the monitor was very instrumental in that aspect. Okay, it says the monitor places a job in the user program area. Monitor controls the sequence of events. So it also schedules and it determines which programs are executed first. Resident monitor is software. Software is always in memory. Monitor reads in job and gives control. Job returns control to monitor. So the key thing that you got to understand about the monitor is that it's a program, but it's a program that's always in memory, and it operates like a lightweight operating system, which in modern operating system it's been replaced by the term called kernel, but the kernel still performs essentially the same tasks. So if you just assume that the diagram on the right-hand side of the screen was a memory, okay, was RAM. We say the resident monitor will take up a certain portion since it's always stored, it's always running, located on memory. Obviously, this happens once the computer switches on. It deploys itself to the memory because we know memory is not permanent storage, so it happens at runtime dynamically. So what happens is when the computer turns on, the monitor will sort of deploy itself onto or reserve a portion of the memory for itself, for its own programs, which manage interrupt processing, device drivers, job sequencing, and control language interpreter, interpreting the different languages, whether it's Java-based language, VB.NET to C# and so forth. So it will install all of these programs and reserve this portion of the memory for itself. So then we have this portion left, which we refer to as the user program area. Okay, so whatever programs the user runs on the computer, they will only be able to access this portion of the main memory. And you may have seen this in a lot of places. You go and buy additional memory. Okay, maybe you buy an additional 2 gig. Now you have 4 gigs on your computer. But if you check how much you can actually use out of that 4 gig, you'll find that you cannot use the whole 4 gig. Maybe you can use 3.5 because the rest is taken up by system programs such as the kernel and the monitor and the operating system itself. So these are the types of operating systems, and you can see from this particular diagram that these operating systems have evolved, that they've improved, where we started off with serial processing systems, which operate in a linear sequential manner, which means one task starts, it finishes, then we punch in the next one. So we manually punch in these tasks and we process them same time, which is seen to be inefficient. So then it improved and we have simple batch systems, okay? And then after simple batch systems, we have multi-programmed batch systems. Simple batch systems operated in the same manner as uni-programmed batch systems, okay? And I'll explain later on. Then we also have time sharing systems, which is a concept that we still find in modern operating systems, okay? So let's sort of break this down. So the term batch means it's something that's done as a group. So if you are processing in series, it's inefficient. And I tend to make an example of a customer going to a retail store to pay for a purchase. So you go to the teller and you pay for the purchase. If that transaction is processed now, you can imagine how many customers they actually get per day. It means every single time a customer is paying, we are processing the transaction in series. That is unsustainable. The amount of trips made back and forth between your system as the retailer and the bank systems in a day will be so much, and there'll be so much of traffic, okay? Sometimes maybe transactions will tend to collide, okay? So how do they fix this issue. They fix it using batch processing systems. So after the whole day, the transactions will go through and they'll get added to the batch. Then after the business day, the bank's systems will process these batch of transactions together as a group. It's a more efficient way of doing it, but also it would save the retailers a lot of money, because imagine the transaction fees they'll pay if they are processing these transactions individually. Some people go and swipe a 10 Rand chocolate. Imagine the fees you'll pay. You probably pay 11 Rand for a swipe, and the person is paying using a card, a chocolate using a card. So the reason why they allow you to do that is because they know that our transactions are processed in batches anyway. So we'll send you all the monetary value at the end of the business day. It doesn't matter. So that's the convenience of simple batch systems. But they do obviously have a lot of shortcomings, and there was room for improvements. There's always room for improvement when it comes to technology. We're just waiting for somebody to be able to identify it. Okay, so moving on. So then we have uni-programming batch systems. Okay, before I move on to this, is everybody still happy? Any questions so far?
No further questions, sir.
No questions. 81 people, no questions. I'm getting concerned. Okay, so which means everybody's happy. So yeah, feel free, guys. Don't be shy. That's the purpose of today, because we already had this lecture. So we say then, uni-programming batch systems, how do they operate? And in case you've forgotten, I just have to go back to this slide. So you need to be able to visualize this, the monitor and the importance of the monitor. We said the monitor takes up this portion of memory for itself and then reserves this portion for user programs. Okay? So when we talk about uni-programming batch systems, we say that there is an issue, okay? There is an issue because only one program can run here at a given point in time. So only one program can exist within this user program area of the memory. So it does it one by one, okay, which is inefficient. The CPU or the processor is constantly being interrupted while it's performing its operations by input-output operations. Okay, so if we are doing uni programming, it means we're only executing one program at a time. And then if that particular program decides to play a song, decides to print a file, what that means is that the CPU will pause. It will be an idle state. Okay. For example, while the program is printing, that's an interrupt. That's an interrupt by an input-output device. So the CPU it's now waiting. Okay, it's an idle state, which means in terms of unique programming principles, it is unsustainable to do it that way, because while the CPU is not busy, another program could have been using the CPU during that time. Okay, so once this input-output device is done printing or playing a song, then the CPU continues. That's why they have here run, wait, run, wait. So whenever the CPU is running, it's busy. And then it gets interrupted by whatever input-output process. It gets interrupted, it goes into an idle state. So while the program that it's executing is busy with input-output processing, it's waiting. It could be doing something else. It's wasting time. And then it runs again, and then it waits again. Okay, so you can see, you get the point of uni programming, the disadvantage of it. And then we can then compare it, okay? In contrast, we can compare it to multi-programmed batch systems. So multi-programmed batch systems allow for more than one program to exist within the user program area of the memory, which means now if we say program A, program B, and program C, while program A is running, okay, program A can run, and then for as long as program B and C are still in a wait state, maybe pending execution of input-output operations. Okay, so they don't collide because they sort of take turns. So program B will be able to pick up that, oh, look, the CPU is free. Can you please attend to me? While program A is still doing XYZ on the side. Okay, so multi-programming, multiple programs are allowed to exist in the user program area of the memory. Hence, this allows for simultaneous execution while these programs are individually trying to access input-output requests. So just in summary, we say that multi-programming would be more efficient because we tend to refer to it as a multitasking. Okay, so when you say you are multitasking on your computer, you are just opening up all these different programs at the same time. That's exactly what it is. It's thanks to the ability of multi-programmed batch operating systems. Okay, they're able to execute multiple tasks at the same time. They are more efficient. You can see they have a higher throughput rate, so they do more jobs within a shorter period of time than that of uniprocessing. But also, multi-programmed systems require more resources. Okay, so they'll use up more memory, they'll use up more disk space and processor and so forth. And these are just some of the requirements of a multi-programmed multitasking system. It has to be able to process input-output interrupts and possibly DMA. Remember, we discussed these concepts in the first lecture in the overview. And we said hardware will communicate using either one of these. Okay, DMA is more of a privileged kind of thing, but by default, all hardware that's plugged into a computer is going to be using input-output or interrupt requests. Okay, so if a technology has DMA, it means it doesn't have to even consult with the CPU. It can go directly to the memory for address locations, making it that function more efficient. And we find this in graphics card. Graphics cards are so important. They don't need to consult with the CPU. Sometimes graphics cards come with, most of the time actually, they come with their own built-in memory. But if they need to access the system memory, then they bypass the CPU and they go directly for the particular address that they are looking for. So to have an effective multi-program system, your hardware must support input-output requests or interrupt, and possibly DMA for more efficiency. Memory management, okay? Several ready-to-run jobs must be kept in memory, and memory protection as well in terms of the registers, securely storing this data or instructions or programs in the right register locations. And software support from the OS in terms of scheduling, okay? Scheduling these programs to run at different times and to manage resource contention. What do we mean by managing resource contention? We can see in the next slide. If we take, for example, job one, yes?
I wanted to ask a question about DMA.
Yes.
So I wanted to ask, is it practical to make like all the hardware components or whatever work with DMA instead of the interrupts?
That's a good question. What I would like to say is by default, interrupt request is something that is just there. Okay, it's sort of become the standard of communication. What if you're operating on an old computer that doesn't support DMA technology. So there needs to be a common, it's like a common language. Interrupt request are like a common language, sort of like English, okay? It's more of a universal language. So there needs to be, for the operating system, a universal language that is understood by all hardware manufacturers, okay? It's good if you can speak another language, which is DMA, which is more convenient, but that's only for special purpose hardwares. I don't think someone who's manufacturing a mouse and keyboard may need to use DMA, quite honestly. Just if you just think about it, there's no need. That kind of device can still use interrupt request. Okay, so I hope that answers your question, Vusi.
Yeah, I was just thinking, like, wouldn't it be like, or isn't it possible to just make like the whole computer or the whole system just use DMA? Wouldn't it be like more efficient or faster and like have like a better performance or whatever?
Only they do it, it would, but at the same time, what's the purpose? Okay, DMA exists because there's a need for it. There's a need for certain hardware components to directly access, but others do not have to do it that way. Okay, they can afford to sort of do the process of interrupting, and that's why if you can't really compare the role of a mouse and keyboard to the role of a graphics card. Think about a graphics card when it's at its optimum performance, how much it actually really needs to bypass the CPU and not wait for the CPU. So certain hardwares, for them to be able to function by default, DMA must be intact. But so we can't make DMA a default, because then imagine if all input outputs devices were able to bypass the CPU. To some extent, it may end up compromising the CPU itself. Okay, so yes, Zolile, I see you also have your hand up.
Yes. Yes, sir.
Yes, you can ask your question.
So, in terms of the advantages of multi-programming batch systems and in uniprogram, what are the disadvantages of multi-programming batch systems?
What are the disadvantages of multi-programming?
Yes.
I would say it's gonna be, and I wouldn't even classify this as a disadvantage. I would say it's the fact that it requires a lot of resources. So for you to be able to operate, most modern operating systems use multi-programming, multitasking. They allow for that. That's why modern computers require all of these high-spec hardwares. Okay, they come out the shop with, now by default, I think you can't. I don't think you're gonna purchase a computer in a store with memory less than 2 gigs. So they've noticed that. That's why technology is getting more and more expensive. Okay, because of these capabilities built into the operating systems and the need for hardware to be able to accommodate for that. So when multitasking first took off, they realized that there is a need now to include more resources into our computers. So I think the only thing I would categorize as a disadvantage is the fact that it's expensive to set up. Okay, technology is getting more and more expensive because of multitasking and multi-programming principles. However, on the other hand, if you had to ask me about the disadvantages of having a computer that is uni-programmed, we spoke about them. Okay, it's definitely inefficient. Executing one thing at a given point in time, it's an efficient use of the CPU. Okay, so I hope that answers your question.
It makes sense.
Yes.
Thanks.
So it's because multi-programming is an evolution of uni-programming. It means we can't really say they are Okay, I actually remembered one additional thing, is that the other disadvantage about multi-programmed operating systems is if it's purely multi-programmed, it means there's no human interaction. It's still a batch processing system. There's no human interaction there. It means somebody triggers an automated process at the end of the business day. And that process runs on a clock. So for example, it's going to take 10 seconds for this batch to be processed. The only difference between uniprogramming and multi-programming is the fact that at the same time, this in memory, okay, in terms of memory, there'll be more programs in memory, right? So what we say is, in terms of multi-programmed systems, there's no human interaction. It's an automated thing, okay? And you understand this better once we talk about time sharing. You'll be able to sort of compare the differences. Okay, so we were talking about contention for resources, and we said that the requirements for multi-programming is that in terms of hardware, there must be input-output requests and possibly DMA where possible or where needed. There must be proper memory management. There must be memory protection. Then we also went on to software support from the OS. It must support scheduling of tasks, okay? Be able to schedule these tasks to avoid collisions, to manage resource contention. So if you go on to the next slide, you're going to see there are 3 jobs there. Job 1, job 2, and job 3. So in terms of multi-programming principles, these jobs can all run at the same time. Why? Because there is no possibility for collision. And in actual fact, that is the architecture that multitasking is based on. The fact that we look whether the CPU or a particular resource is not busy. So we let the next one access it. And we can see here, it says, if we take job 1 is not using the disk, is not using the terminal, is not using the printer. Okay. Job 2, however, is using the terminal. However, there is still no collision between job 1 and job 2, which means they can run simultaneously. And then we have job 3, which is using what? Using the disk and using the printer, but not using the terminal. The only job that's using the terminal is the what? Is the second job, job 2. So in terms of multitasking principles, the operating system will sort of look at the jobs or the programs which do not contest for resources and execute them at the same time. There's no collision, there's no contention. Okay, so moving on to time sharing systems. So batch multi-programming does not support interaction with users, which means batch multi-programming is an automated thing. It happens from the system side and it assigns maybe the process X amount of time. They say executing this process will take 10 seconds. Within that 10 seconds, the person just press start and everything happens towards the end of the execution. And then we say time sharing systems extends multi-program to handle multiple interactive jobs. Okay, processes time is shared among multiple users. Multiple users simultaneously access the system through a terminal. So this is the typical client-server architecture setup, where things are now not processed in batches, but they are processed in real time, okay? Which means it's literally a user sitting in front of the computer and accessing this resource now, okay? It's improved because things happen in real time and also efficiently. So this time sharing sort of strikes the balance between uni-programmed principles and multi-programming principles, okay? But it says that the users are actually sitting in front of the computers, and I just want to move to the next slide. So let's say we have 6 users. on this particular network or using this particular or accessing resources to the server. Let's assume that this is a client server setup, okay? And all the users are sitting in front of the client and they're accessing a server, a centralized server for resources. In terms of time sharing principles, all of us can sort of trigger or execute tasks, but we're all sharing the processing power of this CPU, okay? And in terms of time sharing principles, there needs to be concurrency control. As much as we're all sharing, but we don't see it, it's happening in the background, but the operating system is able to say, look, user 5 is in its active state, so the other users have to wait, okay? Then after user 5, then user 6 is in its ready state to start its operations, okay? So the users don't actually see that's happening. This is all managed, it's scheduled by the operating system in terms of scheduling principles. So time sharing is real-time interaction. Unlike you asked me about the disadvantage of multi-programming. That's the disadvantage of it. It doesn't allow for human interaction, okay? But again, with time sharing, what would you say the disadvantage is? The disadvantage is that there is a security risk because now the users are directly part of the process and they're sharing the CPU and they're sharing the server, which means we need to enforce proper security measures to protect this data, okay? So they're all accessing a centralized computer, which is allowing them to share the CPU in real time. And then we also spoke about the concept of multi-threading. And if you can remember in the first study unit, in terms of the CPU, we said the CPU can either be multi-core, which means it has more than one core. It can execute multiple instructions at the same time. Or we can have a multi-processor computer, which means it's separate physical chips within one computer. And we normally find that on server machines. So what is multi-threading and how does it relate to this concept? So we say a program that wants to be executed can be divided into threads and use the closest and most available CPU. Okay, so we take a job, can call it a job, a program, or instruction. We divide that particular job into different sections, which we call threads. And if our laptop or our computer has a multi-core CPU, it means each thread can take the fastest route to get executed. So it's one of the technologies that come along with modern CPUs, allowing for multi-threading, okay? And virtual memory. So we have primary memory, which is also called physical memory. Then we have virtual memory. So when do we need virtual memory? Exactly. So you have a situation where on your computer, you have 6 gigabytes of RAM, okay? Which is very good, it's not bad. But you're trying to execute an operation which requires 8 gigabytes of RAM. So what happens? Does your computer crash? Who wants to take a guess as what happens? In actual fact, this concept, virtual memory, if you've gone through the study guide, you're gonna realize that it's actually a separate study unit altogether. There's so much we can say about it, okay? But we'll save it for the time when we do that study unit. So anybody want to take a guess? What happens? You're trying to run a software that requires 8 gig of RAM, but you only have 6. Does your computer crash? That's the question. Who wants to take a guess as to what happens?
Like if you're running a game, sir.
It's gonna? Yes, if you're running a game, people who play a lot of games would experience it a lot.
No, it won't crash.
It won't crash. What would happen?
Lag very bad.
Okay. It will
shut down
lag.
and tell you that you don't have to set system requirements.
Okay, so that's one. Abdullah, what do you want to add to that?
It won't download. It will just stop. It won't download.
It won't download, it will just stop.
Yeah.
Okay. Now, two things can play out, and you guys are correct. Two things can play out. So sometimes it crashes, okay? When I say crash, it doesn't run at all. If you're being ridiculous, if the game requires 8 gig and you only have 1, the game is probably laughing at you. If it could laugh, it would probably laugh at you in the background. Because how can you run an 8 gigabytes worth of game on a 1 gigabyte chip? So it will just generate an error there. But from your computer, you have 6 and the game needs 8. It may try to make a plan. So then what does it do? It has to go and borrow from somewhere. Okay? And we say it goes to borrow from where? From secondary memory or the hard disk. And you guys mentioned something about a lag. So you can't really purely rely on virtual memory because the computer uses virtual memory when it's desperate. Okay, so during the process of the computer going from the RAM to the virtual memory, what happens? You experience the lag. Okay, so the game is still able to function and operate, but in between you're going to experience a lag because now the computer has to make a plan. The CPU says, hey, I'm looking for this task. It goes to the cache memory. Obviously, it's not going to be in the cache memory. The cache memory is very small and it stores the most recently executed tasks. So most likely something like a game you would need the whole game to be stored on the main memory, and then the cache will just access it from the main memory, maybe 10 units per trip. Okay, so the whole game needs to be stored on the main memory, but we have a problem because the game is 8 gigs, but the RAM is 6 gigs. So there'll be something called a mapper component that sits between the hard disk and the RAM, and it will just sort of keep on borrowing for anything that needs to be now taken from any additional memory allocations that are required. We're short of 2 gigs, so it's going to keep on borrowing from the virtual hard disk. So we say virtual memory is an ability of the RAM to use, or the CPU rather, to emulate or use the hard disk, our hard drives, our flash drives, have some sort of borrowed virtual memory, okay, to support the primary memory or the RAM chip. Not to be confused with virtualization. Okay, virtual memory and virtualization are two separate concepts. Okay, so fortunately, we're gonna still cover these concepts individually in the later study units. Virtualization is a concept which we use our computer resources to emulate another computer. So if you wanted to run an operating system on your computer, but you do not want to format, maybe you want to try the new Windows, but you don't want to format your current computer because you have all of this information that you still need. Okay, so what you can do is you can do virtualization. How does virtualization work? Well, you get software that allows you to do virtualization, VirtualBox, VMware, and so forth. And these allow you to use, so basically your computer, your physical computer will become the host operating system. And then whatever operating systems you install using a virtual machine will be referred to as a guest operating system. So it's the ability to run multiple operating systems within an operating system itself. And then I think this is the last concept we'll talk about, which is the client-server model. Okay, the client-server model is a model that is responsible for distributing computing, such as operating system services, environment subsystems, and applications. So when you talk about the time-sharing concept, it's based on the principles of client-server access. So a workstation or a person or user is sitting in front of a client and accessing these resources in real time from a server. It says it simplifies the execution or executive. It is reliable. It provides a suitable base for distributed computing and provides a uniform means for application communication with services. I just want to show you this diagram quickly on this last slide. So this is how a typical client-server model would look like. Okay, so thanks to time sharing principles, okay, we are able to access resources directly. So we have these multiple workstations. Does anybody have a question? I hear a mic that's unmuted. Okay, so we are saying that this is the client-server model, and thanks to obviously the concept of multi-programming and time sharing, we are able to now better support our computer networks. So in a typical distributed system, all of these are clients, workstations, and personal computers. They are clients. They access the servers through the network. So these computers share these processes within these servers. They share the processes. Okay. However, in distributed systems, the workstations themselves have localized processing. So we've reached a point where we've added to this time sharing concept by the fact that workstations themselves can help with the processing capacity. And what do I mean by this? So let's say the servers are very busy and they're under pressure. The workstations can still process because they have their own CPU, they have their own RAM, they have their own hard drive, which means they're able to share their resources with the entire network. Typically, in olden day systems, if I was opening up a program like Microsoft Word, I'll be actually opening it up from the server. Okay, so all the time sharing systems, we're all opening it up from the server. You're opening, this client 1 is opening up Microsoft Word from the server, client 2, client 3, and client 4, which is inefficient because the server can be under pressure when simultaneous users are accessing at the same time. Hence, you saw in terms of the time sharing diagram, they have to go through sequentially. Okay, so in terms of distributed systems, we've added the ability for localized processing, which means a program like Microsoft Word, the computer doesn't need to access that program from the server. It can launch it locally because it has its own RAM, it has its own CPU, and it has its own hard drive and system bus. So they actually assist and share the resources with the entire network. Okay, so that concludes our session for today. And is any other questions that you may need to ask or may want to ask?